Florence 2 is a model released by Microsoft. It just came out in CVPR 2024, and this is a vision language model with great functionality, with amazing tasks that it can perform with around zero supervision. And in this video we're going to go over Florence 2. So I'll give a brief overview of Florence 2, and I will share a demo with you, and then we will go into some of the code to see how we can use Florence 2 for some of the tasks that we can perform. Welcome back to the channel, guys. My name is Dhruv. At Convolve AI, we assist medium, small, large enterprises with their computer vision and AI related problems, and we offer them unique solutions. If you want to have a chat, if you want to discuss, or if you want to just have a brainstorming session about your specific problem or about anything in computer vision and AI, here is our contact information. Just reach out to us. I would be happy to chat. All right, guys. So Florence 2, here is the paper. The title of the paper is Advancing a Unified Representation for a Variety of Vision Tasks. So they are trying to unify language and vision here. This has been published in this year's CVPR conference. If you want to go into detail, you can read the paper. It's a very nice paper, and the model's performance is also very good. Overall, you can see that there is an image encoder which encodes the image, and similarly there for the text prompts, there is a text-based encoder which will create a text embedding. All of this together is fed into transformer encoder and transformer decoder, and from there we get the text plus local location tokens. And essentially if you go to the Hugging Face page for this model, you can see all the tasks that this model is capable of performing. So here are all the tasks. It can perform captioning, detailed captioning, more detailed captioning, caption to phrase grounding, object detection, dense region caption, region proposal, OCR, OCR with region. So there's a lot of different tasks that this model is able to perform. Here is a demo. So let me show you maybe a demo. Here you can select the model. There are different kinds of models: large FT, base, and all of these models have different sizes, different number of parameters. For any fine-tuning task, it's better you use the base model because it does not use that much of memory. But you may have to, for the large model, of course, has more parameters, so will give slightly better results. And these are all the tasks that can be done, right? So there's captioning, detailed captioning, more detail, dense region. So what we're going to do in this video, I'm going to show you a demo, and then I'm going to show you how to do all of this in code, how you can load this model in code and run in code all these tasks with Florence 2. So let's maybe take an example here. Okay, so here is this input image. I'm going to use this image for code as well, so it's better we use this for the demo as well. And if you do object detection, here is the output. It's able to detect all these objects, doors, and all of that, right? Instead, if I do detailed caption and give it a command to run, let's see what we get here. Output is green car parked in front of a yellow building, right? So here we can see the caption already. Maybe if I do a detailed caption, it was actually outputting. It does not output an image for a detailed caption. The image shows a green Volkswagen Beetle parked in front of a yellow building with two brown doors. The sky is mix of blue and white, and there are a few green trees in the background. So you see this caption is very well done, right? Now let's try maybe dense region caption and see what we get. All right, see, for dense region captioning, it gives you the particular bounding box for the region and a detailed caption about it. So it detects wheels and all of that. Maybe let's try segmentation. Let's try maybe referring expression segmentation and see what we get. Yeah, it just segments this. Of course, you have to give it some expression as well. So here is basically an example of how this model can do all these tasks, and this is the demo of that. Right now, let me show you the code. Now this is a sample notebook Microsoft, they had already published this notebook to execute Florence 2, and we will go over this notebook. We will go over the code and I'll show you how this works. So guys, we of course start with importing the transformers, auto processor, and auto model for causal LM library. So this is essentially the backbone on which these models are built. So you need these libraries in order to load these models. We are loading the image library PIL requests because in this code we are requesting images from the internet, so we need the requests library to be able to query that and copy, right? So this is pretty straightforward. Here we define the model. Okay, so here we've defined the large model for Florence 2, and just by running this command auto model for causal LM from pre-trained, it's gonna basically load the models. It's gonna download the model weights for this Microsoft Florence 2 large model from the repository, and it's gonna load it over here. Similarly, there is a processor, so those weights will also get loaded here, right? So we have loaded the weights that go into the model in these lines, right? So here's a function that is essentially running inference. The way this function is going to work is we give it a text prompt and text input. Okay, prompt is essentially we're telling it what we want to be done, right? And text input is any additional information we want to give it. So for example, prompt would be do object detection, right? There are specific ways of specifying these prompts. So over here you can see the prompts for different tasks. So if I want to do object detection, I'll use OD as the prompt, and then if I want to input some other text, I can also do that for instructions. This most cases you won't use this, but yeah, there's an option. Processor text input, text equals to prompt, image is equal to image. This is the image on which you're trying to run it, and this essentially creates your setup for the model, and over here you run the model through these lines, and you return the output from the model, right? Now guys, let me show you an example here. So this is a URL to the image, and this is the image, right? You can obtain that image from this URL, and once we have this image, now we can run our queries or we can run inference on this model. Now just to kind of go into the details, here we are doing like initiating a processor, right? We are initializing the processor with that particular text prompt. Then we are generating the IDs to be able to execute the inference, and then we are decoding the IDs to get the final output text, and then we post-process the text to get because the output of the model may be in the form of tokens and numbers, so we post-process it to get the final text answer that we want, that is human readable, right? Now here is captioning task. So I can give it a caption task, and if I run this example, this is the image which is stored in the memory, so we don't pass it in. It would be better if we pass in the image separately, but anyways, this image is in the memory. We run the example and we get a green car parked in front of the yellow building, right? Similarly, we can run detailed captioning, and you can see similar result as we saw in the demo, right? Except this is done in code, so you can incorporate it in your specific workflows as well. All right, so next we come up with the task of object detection. So we give it a task prompt of OD, and the results are, it gives us the bounding boxes for different objects, right? It gives us the bounding box coordinates. This is top left XY and bottom right XY for each bounding box, and this is a function, matplotlib function, which will draw the bounding box and give it the caption based on the class labels, right? So it also outputs the class labels. So you can see without any specific fine tuning on this image or any specific training, it's able to find the door, wheels. It's not able to find this window. Probably it's a window, but still it's able to do the object detection, right? Then there is dense region caption, wherein it gives it does the object detection, along with it gives some dense caption. It gives a detailed caption for that particular object, right? In the case of object detection, it just said car for this, but now it's giving more detail that it's a turquoise Volkswagen Beetle. Okay, region proposal. So region proposal in object detection is a way of finding regions of interest, and the idea is that you're trying to find regions in the image that are interesting and that some user would want to look at, right? So here they have a task called region proposal, and it outputs the bounding boxes. So it's able to find the proposal region for the door, the window, the car, the wheels. So almost everything that you would want to see, it's able to predict a region proposal for this, and without any specific training on that. Phase grounding. So this was kind of confusing for a lot of people, but essentially phase grounding is that based on the given input caption, the idea is to determine bounding boxes, right? So here the phrase that you're giving is a green car parked in front of a yellow building, and you tell it to do caption to phrase grounding, which means that, you know, this is my caption, now find the things that are mentioned in this caption and give me the bounding boxes. So it's able to find the green car and it's able to find the yellow building, right? So both of the things have been segregated in the image by the model itself. The next is referring expression segmentation. So what this basically is that this is the output. It's a long output, but essentially what you're doing is you're telling it to segment different objects in the image, right? So it's basically same thing as a semantic segmentation kind of thing. When we run this and we give it a text input saying that just find the green car in the image, right? After running this, it's able to give the entire polygon for all the pixel locations for all the pixels that belong to that particular class, right? That particular task, for that particular task. So here you can see the output. So this function basically is nothing but basically to get the segmentation mask with polygon on an image. Guys, we will be uploading this. This code is available in the description. It's on our GitHub page. So if you want to go try this out, you can find it there. And here you can see the car has been segmented. The next is region to segmentation. So what exactly does this mean? Here, you know, you want segmentation, but you're giving it a specific region, you know, only segment this part. So you give it a bounding box and through this input, and then all it does, and by the way, the input format is location underscore x1, y1, x2, y2, where x1, y1 is the top left of the bounding box and x2, y2 is the top right, bottom right. What you're essentially doing is you're telling it in this format loc underscore x1, loc underscore y1. It's very important that we make sure we follow this particular format. So we give it this text prompt along with the input, and it's able to segment the wheel only. So this was the bounding box for the wheel, right? Pretty cool, right? So it's very powerful, right? This model, there's so many different tasks you can do just by simply loading the model and giving it those prompts, right? Next is open vocabulary detection. So basically you can tell it what you want to detect in that particular image, and it will essentially detect that, right? So for example, here you give it the task as open vocabulary detection, and input is a green car. It will look at the image and it will find the green car in the image, no problems. This function is just to basically draw the get a bounding box from the output. So this is the output, and to get it the object detection format, we use this function. It's pretty straightforward. Okay, the next is region to texts. So essentially what this particular task is that sorry, yeah, so this one is the first region to text has two different subtasks: region to category and region to description, right? So essentially you give it the bounding box for the object of interest, and it will tell you what that object is, right? So for example, here in the input we give it the bounding box for the car, and it's able to output car for that particular bounding box, right? So it's able to categorize that particular object in the image. Next is region to description. So region to description is also another task where you give it a bounding box for an object and it's able to describe that object, right? So we give the same bounding box for the car, which is able to describe it more. It says it's a turquoise Volkswagen Beetle, right? So not just saying that it's a car, but it's a turquoise Volkswagen Beetle, right? All right, OCR. This is pretty cool, right? So this model, if you go here, it has the ability to do OCR as well, right? Of course, this image does not have any text, so we can't use it, but it can essentially read text in the image, right? So as an example, you give it this image. This is the image that we use as a sample. You give it a text prompt as task prompt as OCR, and it's able to essentially decipher, right? It's able to say CUDA for engineers, which is over here, and introduction to high performance parallel computing, and it's also, it did something here. Oh yeah, so it also read the author names, right? Duane story time, and spaces are a bit messed up, but it's able to read everything properly. You can also give it OCR with region tasks. So basically you can define a region in which you want to perform the OCR, and it's able to do that. So yeah, again, what it will do is it will find the text and the bounding boxes around those regions. For example, it's able to output a bounding box for this particular text, CUDA, and then for engineers. So in this case, you just tell it that give OCR with region. I just want per region, give me the output and the bounding box, and it gives you that. So not only can you do tasks, one-shot tasks, but you can also cascade different tasks, right? So for example, first you can use captioning, and then you can use phrase grounding, right? So captioning will give you a caption for the image, and then you can use that caption as an input to phrase grounding to further obtain the output. As an example, again, we get the car image here. First we get the caption out of the model. So this run example will get the output from the caption output, which is a green car parked in front of a yellow building, right? And then we take this input and we run it on the task caption to phrase grounding with this as the input, and it's able to again from the caption separate those objects and also draw the bounding box for those objects. So you can cascade different things. For phase grounding, caption to phase grounding, you don't need to manually define phrases. You can use captioning functionality to get a caption for the image, and then from there you can do phrase grounding. So that is where this is very useful. Again, you can do the same thing with detailed caption. So in this case, the detailed caption image shows a blue Volkswagen Beetle parked in front of a yellow building with two brown doors surrounded by trees and a clear blue sky. And it will now essentially detect every single one of those things. You can see the Beetle, brown doors, trees, clear blue sky, and it's really powerful. So you can do more detailed captioning. Same thing, even more things in the image will be captioned. So it based on this more detailed caption, it will detect more, but this can also lead to more false positives. So I'm not sure if this will be very useful, but overall it is very powerful that you can do all of this through this particular model. So guys, if you want to try it out, try the demo. The link is going to be in the description of the video, and then read this page as well, right? It will give you an idea, and then try this notebook. And then there are ways you can fine tune Florence 2 on your own data set. We will talk about that in the future. But in this video, I wanted to give you an idea about what Florence 2 is and what its capabilities are. So with this demo and with this code, you can see how powerful this particular model is and how we can leverage it. So to summarize, guys, we have gone over how Florence 2 can be used with the demo online and also through code. If you want to pick the model off the shelf and use it on your specific data set, you can try it and code using the code that has been provided in the description of the video. Again, this code comes from the Florence 2 authors themselves, so full credit goes to them, and you are free to use that code. Now, if you would like to know more details about Florence 2 or know how to fine tune Florence 2, we will do more content on that. If you really like it, just leave a comment so that I know, and I'll prioritize that above other things. Thanks again for watching, guys. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new computer vision AI related videos that we upload. We are gonna upload content to help you stay relevant, to help you stay updated about everything that's going on in the vision world. And these vision language models, Florence, Polygemma, all the ones that are coming through CVPR are some things you don't want to miss. Thanks again for watching, guys, and I'll see you in the next video.